Hello and welcome to a very important topic in relational database. It's called normalization. What is normalization? Is the process of removing all the anomalies. Anomalies is a keyword that means some problem that exists in the database. We need to remove them. There's all types of anomalies. We're talking about insertion anomalies when we insert data in two different places, and they contradict each other. A person has two different addresses, for example, or a misspelled last name. Then we have an update, also where it's going to be updated in one place, but it's not going to be updated in different places. And also we have cascade anomalies. Most common anomalies that you could probably think about is data redundancy. We have a lot of data that is not needed, takes a lot of storage, and also it creates or wreak havoc on some of the reports that we do usually in a relational database. To make it a short story, I'm going to be looking at a table that has been provided to me through a spreadsheet, Excel spreadsheet, and it's basically talking about this set of data where we have a list of students with their majors and their first last name, major name, number of credits, the start date that they enrolled in each of those majors, and the department that supervised the major, and also the department name. So if you take a look of the very first thing that should immediately get our attention is the fact that some of these cells have multiple values. So when we're talking about the major, we have an IS in English. Also, we have double values here, double values here, double values here. So, for example, if we want to keep this in a database, maybe the person is going to have a math, computer science and information system, but because they ended up entering the same piece of data here, they might misspell that, or maybe they will enter a different word that has nothing to do with the department. So you could see how easily the data can be distorted. So in order to go through the normalization process, we have to go through in at least 3 steps, or 3 norms forms, as we call them. The first norm form is to remove all repeating data, meaning there is no 2 values in one cell, because this is supposed to be looked at as a table in the database. No one cell has more than 1 value. So somehow we have to remove all these duplication and associated with 1 value. In addition to this, we have to after we remove the repeating groups or repeated data, we have to really find a primary key for each entry. If you take a look at this one here, before we do anything else, you might say, yeah, this is a student's ID. I could be able to identify that this ID, this person, Jack Nicholson and Julia Roberts and Tom Cruise, belongs to this one here. And of course, I'm going to enter all this sort of data, create data redundancy, mistakes, all sorts of things. But I still have the ability at this stage to identify each entry by the student's ID. Of course, in order to get into the repeating group, which means the very first step of going through the first norm form, is to not allow more than 1 single value in a single cell. I mean, 1 single value in a single cell. So if you notice here, I'm going back to the student's ID, and his major, or his major in this case, is computer science. I put his name. Of course, that was 1 entry, 1 major, so everything is entered. Knowing that this person here, right away we have another issue here, so we could go ahead and add another 2, because we need to make them consistent. The second person has the student's ID 2222, 6 of those digit 2s, and since it's the same person, in order to break the repeating group, I had to repeat Julia Roberts multiple times. And also because of her major name, I mean, major name. She has two majors, so we had to break those into the number of the credit finished in each major, and also the date she started each major, and the department that that major belongs to in the actual name of the department. So also notice the same thing for the third person, Tom Cruise. I had to repeat his student's ID in order to make it a unique value and remove the repeating group. So we have here 3, 3, 3, 3, 3, 6 of those threes, and I had to break the major into 2 cells, and each cell is going to be a single entry. So far, by removing the repeating group, we ended up actually getting more data initially, because we had to type the student's ID multiple times, but that's actually guaranteed that we will have a single entry per row, or per tuple, per a horizontal entry, as we call it, a record later. So if we take a look at this one here, in order to determine the second requirement, in order to prove that this is the first norm form table, we have to look for a primary key. Before, we took a look at the student's ID, and we thought this is enough to identify the individual, whether she or he listed 2 or 3 times, because the student's ID is unique. Now we have to look at it differently, and you need to focus with me on this point. Since I have the student's ID, and we're talking about first norm form, we're talking about a database, so we're not thinking about the spreadsheet mentality anymore. In order for us to get a primary key, that primary key must be unique, and that's part of the constraint that we have to deal with. Is the primary key constraint is that the primary key must be unique, whether it's a single value or multiple values resulting into a composite key. So the fact that this one here has a student's ID being repeated, 1, 2, both of those are repeated, and those also repeated, so there's no way I could choose the student's ID anymore as the primary key. It's repeated, so that violates what we call the primary constraint. So I'm going to look for another piece of data that maybe, or 2 or 3, who knows, that I have to join those together in order to create a composite key will assure me that it's going to identify each entry uniquely. All right, so we took a look at the major here. That's a good candidate for it. You might think about another one. There is no way we could really use the first name that could be constantly repeated. You know, we can see here Julia and 222. Julia is 222. That's that question. Robert's 222. Robert's the question. And major name, they could have actually a different major name, but its major name is a very awkward choice. Number of the credit is changeable. You know, also the major name could change if that person changes as major or add another major. The starting date, that's changeable, is not accepted. The department is really should not be thought about at this moment, because the department is going to be determined by the major. So I'm not going to really think about it. The department name, of course, and the department all belong to the major. So now I have to look at these two together and see if that is going to assure the uniqueness. Obviously, this piece and this piece together are going to assure the uniqueness for each entry. We should not have a student's ID with the same major more than once in a row, so therefore these two are going to be basically my primary key for entry. Immediately we're going to face this problem that these two have a composite key, meaning 2 of those, could be more, but in this case we have only 2 of them that is going to identify. So if we have composite key, meaning more than one value to make up the primary key, we have to really look for the partial dependency. Anyway, congratulations at this stage, because we already obtained the first norm form by removing the repeating group and by finding the appropriate primary key, which happens to be a composite one. So let's take a look at the second norm form, which means no partial dependency. What do we mean by partial dependency? No one other non-key is not dependent on the entire primary key. So if we see like one piece of the other data other than student's ID and major are not dependent on both of them, then we have to really deal with it as a partial dependency, because it's partly or part of it, it's dependent on part of the primary key, not the whole primary key. Let's take a look at the first name. The first name itself is not dependent on both the student's ID and the major. The major could exist without the first name, without that person ever attending or actually enroll in that major. So this is going to be dependent in the student's ID. Immediately we have to really break that table. And now we're going to have a student's ID as the primary key, the first name. And the same thing with last name. The last name is not dependent on the major. So we have the student's ID. The student's ID is the primary key. It's good to have a name for this table right up in the beginning and say, okay, this is my table, and it's going to call students. I'm going to call students here. We continue. Major name is basically dependent only on the major. So that's going to also be broken into another table. And I'm going to call this table table major. And notice I'm taking the major abbreviation as the primary key in this case, and I put that underlined, same thing here, underlined, to indicate this is my primary key. I took the major name immediately as dependent only on the major, and I will show you what I did with this later. Just don't worry about it at this moment, because I really need to have, you know, the department basically has to be done here. Let me go ahead and scroll down so I'll be able to see what I'm going to be doing here. Maybe I erase that, but I really need to get back to that department here. Okay, department. So in order to make sure department, and also, sorry, department, and of course we're going to have the department name. Forget about those at this moment, then later we'll be able to think about them. So in this case I have only the computer science. I could go ahead and let me go ahead and get that clipboard activated so I'll be able to see what I'm going to be doing here. I could go ahead and copy this, just all the different name of the department. I'll be able to do it. There we go, copy. Okay, and English needs to be copied as well. And also the business will be copied as well. So if you look here at the department, this is basically this one here. And this one is going to be information system, which is part of the math computer science. And we have an English, which is English here. And we have also the business is business here. So the department name is going to go ahead and do that also as well. Copy this one here, copy, and this one here, copy as well. So now we have department name, which is going to be, in this case, going to be this one, and also the second one is going to be this one, and it's going to be as well. For the English, it's going to be English and communication, and the business is going to be business and economics. So this is basically how I did it. Notice I only had to repeat the major name once, and the department name, of course, it's being repeated here because we have more than one department in the same computer science and information system, and the department name, which is really a lengthy wordy kind of text. Anyway, we wanted to make sure that the major name is dependent on the major, the department is dependent on the major, and the department name in this case. We have also to continue with this discussion about the number of the credits. The number of the credits is going to be dependent on both the student's ID and the major. So now, because this is entirely dependent on the primary key, so the student's ID and the major, we could leave it as a table by itself. I mean, if I removed already this, I removed this and this, see, even I removed this and this, that's the major, and I removed basically the department. Here we go. Let me go ahead and do this. This is what I removed already. So it makes it easier for you to realize that what I'm left with, the student's ID and major, the number of their credit completely dependent on that student's ID and the major together, and the start date also completely dependent on the entire primary key, which is the student's ID and the major. That's going to be a third table by itself, which, as you notice here, I copied it and pasted it. So something that I really need to emphasize this, because removing those already, the yellow one already gone to the other tables, the students table students and table major, and this one here we're going to go ahead and insert a row here to call it appropriately, which is going to be table both students and major. So now we have a 3 table, and we're going to go over this is very carefully. Now we have to notice that in this case I have the students major. Those both are primary key, both of them primary key. This is a single primary key, and this is a single primary key. So if you take a look at this, this is entirely dependent on the primary key, entirely dependent on the primary key. The major name is entirely dependent on the major. The department is dependent on the major, and also the department name also dependent on the major, but in the partial dependency discussion here. There is other type of dependency, we'll get to it. Notice that the start date is dependent on both student's ID and the major. Here we need to have student's ID, of course, okay, to make sense out of this. And also the number of the credit will be dependent on both the student's ID and major. So the result of this, and now we notice we have those 3 tables. Let's go ahead and get rid of this for a while, and I'll go ahead and put it somewhere else down. You know, I'm going to go ahead and put it right here for now, so it doesn't confuse us. And as you notice, we end up here with the 3 tables. Okay, the table major, the table the students, and the table students major. This is basically where my transaction table is going to be. Only I'm going to enter a students if a student's enrolled. Again, I'm going to insert a major if there is a major being declared. And the student's ID and the major, of course, is going to always have the same number of the data entry at the beginning. Here I copied it wrong, but it's basically, we'll have to be a little bit more careful about things like this. So we need to look for the partial dependency one more time. There is no partial, we passed the partial dependency, no partial dependency here, no partial dependency. Everything is dependent on the primary key. Both of these are dependent on the primary key. So the primary key for this table is both. So we passed the partial dependency test. We already moved from the second norm form. We're already in the second norm form as we speak. Now let's move on to testing to see if we're going to really look for the third norm form, which is the key phrase here for the third norm form is transitive dependency. Transitive dependency, clearly it has to do with a non-key being dependent on another non-key. So let's go and look at those 3 that we already have. There is no way we will be having in both of these tables of transitive dependency, because there is no more than one single value acting as the primary key. So the students, table students and the table major already passed that third norm form, because there is actually, both of them are dependent on the primary key. Okay, the first name is dependent on the primary key. The last name will never exist without the student's ID as well. So we could have actually both of them are dependent on the student's ID. The major name on the other part, actually, one second here. I need to retreat myself a little bit or go back a little bit. Those basically, this one here is dependent on the primary key from the previous one, and this is dependent on the primary key and from the previous one. In order to test if this is in the third norm form, the number of the credits should not be dependent on the start date, or the start date should not be dependent on the number of the credits. So let me make it clear. This is what the transitive dependency. So instead of actually talking about the major and the students, these two are already in the third norm form because there's no non-key are depending on another non-key. Okay, there's no non-key is depending on another non-key. If we take a look at this one here, this is where we're going to get into evaluation of the major name. As you notice here, we're talking about transitive dependency, meaning a non-key is dependent on another non-key. Major name is dependent on the major. That already great. And department is dependent on the major. That's fine. If you take a look at the department name, will never exist unless the department exists. So the department name is entirely dependent on the department. And there is a dependency between the non-key department name on the non-key department. So this is what we call transitive dependency, where two non-keys do depend on each other. And as a result, we have to really create a fourth table. We're going to take the department and the department name. Look what will happen if we lift it like this. We put the department name like this, department name like this. Do you see I'm putting here the math, computer science, and information system here? What about if by accident I put here, instead of math, I put mathematics? You know, the whole word mathematics. Or instead of saying English, I misspelled the word English. So I'm going to have two different department names based on the fact that I couldn't really control what I type in the department name every time I had to really mention the department. So if I break the department, you could actually use the department name. I would take the slash. It's not recommended. Or better yet is to go ahead and create a number as the primary key for each department. So it will be easier to add it. And we're going to go ahead and, you know, make sure that I do 1, 2, 3. We have 3 departments. And this is going to be the primary key department number. And also it's going to be department name is going to be described here based on the fact that I have, this is going to be dependent entirely on the department number. And this is going to be entirely dependent on the department numbers. And basically, this is going to make it much easier for us not to enter more than one department name. Look here, the key aspect or the key thoughts. No more than one single department name. So if we really make a mistake here, it's going to be mistaken through the whole database. But if we find out that we have made mistakes here, then it's going to be corrected here, and it's going to be corrected through the whole database. So this is basically, it's going to be a fourth table. It's going to be called department. And in order for us to convince ourselves that we did the right things, the department must be removed from this table here in the second norm form as a separate table by itself, because there will be a transitive dependency by removing the department name and department name, and assign for easy access, for easy reference, department number. It will become in the third norm form. So there is no more transitive dependency. Again, this should be able to help us. What's going to be left for us is to create foreign keys for the table to be linked together. There's nothing to it. As you notice, we have now removed those two because we don't need them anymore from the third. So I'll be removing that from the third. I don't need it because it's already been created. So if I deleted that, here we go, delete all that, because I have the data down in the third one, and I have now a major only with major name. Of course, in order for me to link this to the department, I have to identify you know, which department belongs to which computers, which department belongs to which major. So in this case, the computer science is going to be 1. I can create this here, 1, and this is going to be, let me see here, a lot of scrolling here. It's a big area here. Let me go ahead and close this since I don't need it anymore. Hopefully this will help us a little bit. And as you notice here, a little bit scrolling also. So we have here the 2 is the English and the 3 is the business. So we're going to go ahead and do here. Every time we see anything to do with the major computer science or information system, it's the same department. So we're going to have 1, and here we're going to have 2, and here we're going to have a 3. Of course, this space should never existed anyway, but I did insert it by accident, so we got to remove that. When we move it into a separate sheet by itself, in order to really move it to the database, it's going to look like this. Of course, let's go back to it so I don't get lost here. In the fact here, this is becoming the foreign key. This is becoming the foreign key. So make sure that you understand this, please. That is actually to link us. We don't need this now. Get out of here. And in order for us to get the link between the table major and also the table department, I don't need to worry about that transaction table or this table here, the student's ID with the major, because that's going to be the 1 in the relationship. That's going to be the money, and this is going to be the many, and this is going to be the 1. So these two actually going to be linked in a many to many relationship, but the major is going to assure that it's going to be linked to this, and the student's ID, sorry, the major name and the student's ID are going to be linked to this table, and the department name is going to link those 2 tables. So I assure myself that all the 4 tables are linked, and I'll be able to really build the database in Access or MySQL in a piece of cake. Thank you for watching. I know it's a very lengthy video. It's over 25 minutes, but it should be able to help you through the process, and I hope you will find it helpful. If you do find it helpful, we're thinking about breaking it into 3 different videos, but due to the lack of time, I'm going to go ahead and leave it as one lengthy videos. But if you find it to be helpful, we could go ahead and record more videos for you in the future. Thanks a lot.